Welcome back to my channel. Today we will continue discuss on pre-Pspm questions set 2. So you are given 90 minutes to answer these questions. Press submit after completed. Okay, so you can click on the link below to try the questions. So we will start to do discussion. Questions number 1. The symbol of the dimension of mass, length and time is m, l, t respectively. What are the dimension of force? Okay, so force is equals to MA. Okay, so dimension for M actually is capital M. Dimension for acceleration is LT -2. So the answer is B. Okay, next we go to questions number 2. The motion of the object in a straight line shown in the graph. Okay, find the velocity from t equals to 4 seconds until t equals to 8 seconds. So from 4 seconds to 8 seconds, actually the displacement is still the same, meaning that displacement is equals to 40. Okay, and if you want to find the velocity is equals to the gradient of xt graph. Okay, so meaning that the object is at rest at 4 until 8 seconds. So the answer is B. Questions number 3. An object dropped so that it's continued in a free fall motion. Find its velocity when it has fallen 70 meters. Okay, so the bar initially is equals the bar is initially u equals to 0 because of the word drop. Okay, and then we have g equals to 9.81. So we want to find the velocity when it has dropped 70 meters from the initial point. Okay, so we can use v squared equals to u squared minus 2gs to find the final velocity, where u is equals to 0 minus 2g and s, because it is moving downward. Okay, so we must substitute negative 70 meter. So finally, the final velocity that we will get is equals to negative 37.06 meter per second. Negative here shows that the motion is moving downward. Okay, so the answer is B. Questions number 4. An object is launched at the angle of 25 degrees with the initial velocity 42 meters per second from the roof of the building of the height of 50 meters. What is the maximum height? Okay, so this is the building, and the building height initially H1 is 50 meters. So the object is initially launched at the angle of 25 degrees with the initial velocity 42 meters per second. So we want to find the maximum height, meaning from the ground until the maximum point. Okay, so from ground until the building, we know that h is equals to 50 meters. So we need to find h prime. So h prime meaning that we must find from the launching point A until point B. Okay, so from point A until point B, uy is equals to 42 sine 25 degrees, and we have g equals to 9.81, and when you reach B, actually is maximum point, maximum height. So when maximum height, the velocity is equals to 0. So we want to find sy. Okay, so since we have u, g, v, we want to find s. We can use v squared equals to u squared minus 2gs. Again, v is 0 because it's at maximum height. U is 42 sine 25 degrees square minus 2gs. Okay, so if you press calculator, the answer that we will get sy is actually h prime. So the answer is 16.06 meter. Okay, but the question asks to find the maximum height. Maximum height is 50 plus h prime. So this is our maximum height. So the total h maximum is equals to 50 plus 16.06. Therefore, the answer is 66.06 meter. So answer is B. Questions number 5. 1 kg ball moved to the right with the initial velocity 5 meters per second and bounced back after hitting the wall with the same velocity. Okay, so initially the ball is moving to the right 5 meters per second. After that, it hits the wall and then bounce back with the same velocity. So when it bounce back, meaning that the direction is changing, so we must substitute negative 5 meters per second because the direction is to the left. So we want to find the impulse. So what is the equation for impulse? impulse is equals to change of momentum, or we can write it as mv minus mu. Okay, so m is 1 kg, v is moving to the left, so it's -5, minus 1, u is +5. Therefore, we will get -10 kg meter per second. Question number 6. Determine the final velocity of these two trucks. Okay, so initially, the railway truck of the mass 8,000 kg travel along a level track with 2.5 meter per second and collide with the stationary truck mass 12,000 kg. After that, these two trucks will move together with the same velocity. So we want to find after the collision. Okay, after the collision, these two trucks will move in the same velocity. Okay, so we can use conservations of momentum to find the final velocity, where m1 u1 plus m2 u2 equals to m1 plus m2 times v. Okay, so actually this is inelastic collision because after the collision, m1 m2 stick together. Okay, so initially 8,000 kg truck moving with 2.5 meter per second, and truck 2 is actually stationary, so plus 0 equals to 8,000 plus 12,000 truck times the final velocity. Okay, so 20,000 equals to 20,000 v. Therefore, v is equals to 1 meter per second. Okay, so the answer is 8. Okay, questions number 7. Okay, what are the tension for T1 and T2? Okay, so T1 and T2. Okay, here we have M1 and also M2. Okay, let's say this is M1. M1 is 2 kg and this is M2. M2 is 3 kg. Okay, so if you want to draw a free body diagram, okay, it's actually easier for us to determine the value for T1 and T2. Okay, so for mass 1 is we have a normal force and also we have mg. At the same time, we have T2. Okay, so this is free body diagram for M1. Okay, for M2, there are normal force, mg, tension 2, and also tension 1. Okay, sorry, this one actually is tension 1. Okay, this is tension 1. Okay, so the first equation from M1 is Fx equals to M1A, where Fx for object 1 is only tension. So tension 1 is equals to MA, where M1 is 2 kg, A is equals to 3 meter per second square. Therefore, T1 is equals to 6 Newton. Next, for M2, Fx equals to MA, where T2 minus T1 is equals to M2A. Therefore, T2 minus T1, T1 is 6 Newton equals to M2, 3 kg, and the acceleration is equals to 3. So the final answer for T2 is 9 plus 6, so it's equals to 15 Newton. Okay, so T1 is 6 Newton, T2 is 5 Newton. So the answer is 8. Next, we go to questions number 8, where mass 1 is 1 kg, mass 2 is 2 kg. Determine the acceleration of the system. Okay, so for M1, there is a tension and also mg. For M2 as well, we have tension, and also M2g. Okay, so let us look at M1 first. Okay, because the motion is going upward, meaning that tension minus M1g is equals to M1a. So this is our first equation where M is equals to 1 kg. So therefore, tension is equals to 1a plus 1g. Okay, so this is our first equation. Okay, for M2, because the motion is moving downward, meaning that M2g minus tension equals to M2 times acceleration. Therefore, tension is equals to 2g minus 2a. So this is the second equation. So since tension for M1 and M2 are similar because they are same string, therefore equation 1 actually equals to equation 2. Okay, so A plus G actually equals to 2G minus 2A. So 3A will equals to G, therefore A will equals to 9.81 over 3. Okay, so for questions number 8, the answer is equals to 3.3 meter per second square. So the answer is C. Next, we go to questions number 9. A boy pushed a box with the constant net force 180 Newton at the angle of 30 degrees with the horizontal through the distance of 15 cm. how much work is done by the gravity. Okay, so here by the gravity meaning that we want to find work done by the weight, okay, or equals to mg. So the boy is pushing, okay, a box with the angle of 30 degrees. So this is actually F external. Okay, distance is 0.15 meter. But the question asks us to find work done by the gravity, meaning that we want to find mg. Okay, so work done by the gravity is actually weight times the displacement cos theta. Okay, so weight is mg, displacement is 0.15. The problem is the angle between the gravity and displacement is equals to 90 degree. Okay, so it's cos 90, yeah? And we know that cos 90 actually equals to 0. Okay, therefore, work done by the gravity is actually equals to 0 joule. Okay, so the answer here is D. Question number 10. A car of the mass 1500 kg move with the velocity 10 meter per second. Determine the magnitude of the force required to stop the car in 500 meter by using work energy theorem. Okay, so initially we have M, we have the value for U, and V final is 0, S is equal to 500. Okay, so by using work energy theorem, work done is equal to change of kinetic energy, where work done is Fs cos theta. Change of kinetic energy is half mv squared minus half mu squared. Okay, so K final minus K initial. Force is equals to, okay, force is the value that we want to find. S is 500. Okay, so cos is cos 0 because force and displacement in the same direction. Equals to half m 1500. V square is 0. U square is 10 squared. Okay, so I factorize out half m. So finally, the F that we will get is equals to 150 Newton. Okay, so the answer here is A. Okay, next question is number 11. A student carries a bag weight 5 kg from the ground to his class at the first floor in 2 meter height in 1 minute. Determine the power by the boy. So power equals to work done over time taken, or work done actually for this case is actually equals to mgh. So m is 5 kg, g is 9.81, h is the height 2 meter, and the time taken is 1 minute. So 1 minute is equals to 60 seconds. So if you press calculator, we will get 1.635 watt. So the answer is equals to A. Question number 12. A 200 gram object is rolled in a vertical circle whose diameter is 1 meter. If the time of the one revolution is 0.9 seconds, what is the tension in the string at point A? Okay, so meaning that we want to find what is the tension at point A. So question number 12 actually is chapter 6. Okay, so here we want to find the tension, okay, meaning that at point A there is a tension and at the same time it experiences weight. Okay, and because this is a moving in the circular path, so meaning that our centripetal force is acting towards the center. So the equations that we will get is Fc equals to tension plus mg. Okay, where tension is equals to Fc minus mg. Okay, so here we have the diameter, meaning that we can find the radius, where radius is equals to 0.5. And the information they give to us is 1 revolution in 9 seconds. Actually, they give us omega, where 1 revolution is equals to 2 pi in 0.9 seconds. Okay, therefore F equals to mr omega square minus mg. So we substitute in the value. M is 0.2, R is 0.5, omega is 2 pi over 0.9 square minus 0.2 times 9.81. Okay, so the final answer for the tension is equals to 2.91 Newton. Okay, so the answer is B. Question number 13 is chapter 7. A rocket with the mass 2.5 exponent 4 kg is traveling from the Earth to the Moon. What is the gravitational force of the Earth on the rocket when the rocket is 5 exponent 6 from the Earth's surface? Okay, so meaning that we want to find the force between the Earth and the rocket. Okay, so let's say this is the Earth and this is the rocket. Okay, So the distance between the rocket and from the Earth's surface, h is equal to 5 exponent 6. Okay, but when you want to find r, the radius, actually we need to find from the center. Okay, so meaning that later we need to plus the radius of the Earth. Okay, so force, the gravitational force is equal to gm Earth times m of the rocket over the radius square, where g is a constant value, 6.67 exponent negative 11. Mass of the Earth is given here, 6 exponent 24. And mass of the rocket is 2.5 exponent 4. The radius here is radius of the Earth plus the altitude. Okay, so we can find our r here is equal to 6.4 exponent 6 plus the altitude 5 exponent 6. Okay, so this is our r. Okay, where r is equal to 11.4 exponent 6 meter. Okay, so we substitute into the equation 11.4 exponent 6 squared. So finally, we will get 7.7 exponent positive 4 Newton. Okay, so the answer is D. Okay, question number 14, chapter 7. Determine the escape velocity of the Earth if the Earth mass is 6 exponent 24 and the radius is 6.4 exponent 6. So we want to find V escape. V escape formula is equal to square root 2gm over r. Okay, so we substitute 2g is 6.67 exponent negative 11. Okay, m here we are referring to the mass of the Earth, not the rocket. Okay, so we must substitute 6 exponent positive 24 and the radius, because the question mentioned is escape from the surface, so we must take the radius of the Earth, where it's equal to 6.4 exponent 6. Therefore, the final answer for the escape velocity is equal to 11.2 exponent 3 meter per second. So the answer is B. Okay, next, start from questions 15 is chapter 9. Okay, 15, 16, 17, 18. 4 questions from chapter 9. So the displacement of the particle undergo a simple harmonic motion, and they give you the equation x equals to 8 sine 4 pi t, where x is in meter and t is in second. So we want to find the period of oscillation. Okay, so we can compare with the equation x equals to a sine omega t, where we know that omega is actually equal to 4 pi. Okay, so omega equals to 4 pi and omega also equals to 2 pi over t. Therefore, t is equal to 2 pi over 4 pi. So we cancel off pi. Okay, so the final answer for the period of oscillation is equal to 0.5 seconds. Answer is C. Question number 16. The displacement x for the particle at time t equals to second in a simple harmonic motion is given x equals to 10 sine 20t. Okay, determine the displacement when t equals to 1 second. So we substitute in t equals to 1 second. Okay, so remember here the value is in radian, so you must convert or change the calculator mode into radian, only you can get the answer. Okay, so after pressing the calculator, the final answer that we will get for the displacement when t equals to 1 second is equal to 9.13 meter. Okay, so the answer is C. Question number 17, still chapter 9, simple harmonic motion, where the particle 4 kg move in a simple harmonic motion. And here is the potential energy varies with the position x. Okay, calculate the total potential energy when the displacement is 0.1. Okay, so here from the graph, from the figure, give when x equals to 0.2 meter, the potential energy at that point is 1 joule. Okay, so we can use U equals to half m omega square x squared. This is the equation for potential energy. So we know that when U equals to 1 joule, m is 4 omega squared. At that time, x is 0.2 squared. Therefore, omega squared, we will get 12.5. Okay, so now we want to find when x equals to 0.1, what is the value for the potential energy. Okay, so we substitute into the equation U equals to half m omega square x squared, where we substitute m is 4 kg, omega squared just now we found 12.5 and x is 0.1 squared. Okay, so finally, the answer that we will get is 0.25 joule. Okay, so this is the potential energy when x equals to 0.1 meter. So the answer is C. Okay, or if you don't want, actually you can use the relationship where we know U equals to half m omega square x squared. So we know that U is directly proportional to x squared. Okay, so you can use U1 over U2 equals to x1 over x2 squared to find U2. Okay, so you can use the equation, you use ratios to find U2. Okay, next question is 18. Still chapter 9. The length of the simple pendulum is 0.5. Determine the period of the oscillation. So period, we have two types. For the spring, period is equals to 2 pi square root mass over k. Period for the pendulum is equals to 2 pi times square root length over g. Okay, so since the question says it's a pendulum, so we will use the second equations. So we substitute in the value where L is 0.5 and G is the acceleration, so it's equals to 9.81. Okay, so for questions number 18, the answer is 1.42 seconds. So the answer is B. Okay, next questions number 19 is chapter 10. So for chapter 10, there are 5 questions, so meaning that 19, 20, 21, 22, 23 are chapter 10. Okay, so what is the amplitude of the wave in the diagram? Okay, so we know that amplitude is A. Okay, so here they give you 0.06, meaning that the amplitude here is 0.06 over 2. So the answer is 0.03 meter. Answer is A. Okay, next question is number 20. How many knots, okay, does this standing wave have? Okay, knot meaning that the amplitude of the particle is minimum, is equals to 0. So here we have 1, 2, 3 knots. Okay, so the answer is C. Okay, next question is chapter 10 related to sound intensity. Initially, the sound intensity is equals to 10 watt per meter square. Watt when the amplitude is 1 meter. Okay, so at that time, the amplitude 1 is 1 meter. Determine the value of sound intensity when the amplitude increases to 2 meters. So we want to find the new intensity when the amplitude 2 is equals to 2 meters. Okay, so we know that our intensity is directly proportional to the amplitude squared. Okay, so we can use ratio I1 over I2 equals to A1 over A2 squared. Okay, so initially I1 is 10, I2 we don't know. Amplitude 1 is 1 meter, amplitude 2 is 2. So remember to square. So final answer for the sound intensity, we will get 40 watt per meter squared. So the answer is D. Okay, next questions number 22 is the applications of the standing wave, where the stretch wire initially 100 cm vibrates transversely. The wave traveling along the speed of 230. 4 anti-knots can be found in the stationary waveform between the two fixed ends. Okay, so meaning that this is the fixed line. This is the fixed ends of the wire, where here we can find 4 anti-knots. Okay, so we have 1, 2, 3, 4. Okay, we have 4 anti-knots found. Okay, so A. Okay, want to find the frequency of the vibration. Okay, so since here our length 100 cm or 1 liter length is equals to 4 lambda over 2. Okay, so meaning that our lambda is equals to 2 over 4, okay, or 1 over 2 L. L is 1 meter, okay, or equals to 0.5 meter. So we want to find frequency. Frequency equals to V over lambda, where V is 200 meter per second and the lambda is 0.5. So finally, the frequency that we will get is equals to 460 Hertz. So the answer is D. Okay, the last questions for chapter 10 is Doppler effect. A sound source and a person are located on the same horizontal straight line. The person hears a sound of 550 when the sound is moved towards him. Approaching him, he can hear 520 Hertz. When the sound source passing him and move away, at that moment the observer only can hear 450 because the source is away. So determine the speed of the sound source, and they give you the speed of the sound in the air is 330. So meaning that here we have two cases. Case 1 is when the car or the source is moving towards the observer. So case 1 is F observer equals to 330 plus 0 over 330, because the car is approaching meaning is negative V times the source frequency. Okay, so here we have two unknowns. The first unknown is the speed of the source, and the second unknown is the frequency of the source. Okay, so when we have two unknowns, we need two equations. So we can find the second equation from case 2, where at that moment, the car already passing through the observer and moving away from the observer. So the equation 2 will equal to 330 plus 0 over 330, because it's away, so it's plus V source times the frequency source. Okay, and just now the questions also mentioned that when it is approaching, it can hear 520 Hertz. When it is away, observer only can hear 450. Okay, so this is the second. So this is the second equation. So we can do it simultaneously. Okay, we can use ratio 520 over 450 equals to 330 over 330 minus V source times Fs 330 over 330 plus V source times the frequency of the source. So since 300 and 330 are similar, we can cancel. F source, they are from the same source, so we can cancel. So finally, we will get V source is equal to 23.81 meter per second. Okay, so the answer here is A. Okay, questions number 24 is chapter 11. What is the Young modulus of the wire? Okay, so this is the graph stress versus strain. Okay, so we know that Young modulus is equal to stress over strain. Okay, so we know that actually it is a gradient of the stress and strain. Okay, so we can find the gradient because we have, okay, so we can find the gradient because here we have stress is 750 and the strain is 6. So we substitute into the equation, stress is 750, strain in 6. Okay, so the Young modulus that we can get is equal to 125 Pascal. So the answer is A. Okay, so if let's say we find the area under graph here, okay, area under graph, if let's say the question asks us to find strength energy per volume, okay, meaning that it's actually area under graph. Okay, under graph of stress versus strain energy. Okay. Okay, next questions number 25 is chapter 12. Okay, chapter 11 only one question. Chapter 12 we have two questions. Okay, now we have the glass window with the cross section area 1.5 and the thickness is 0.2 cm. The temperature of the inner and outer surface is 15 degrees Celsius and 0 degrees Celsius, and they give you the thermal conductivity 0.84. So now we want to find the rate of heat flow, meaning that we want to find dQ over dt, and the equation is equal to negative Ka dt over dx. So we substitute the thermal conductivity is 0.84, area is 1.5, temperature is 0 minus 15 over x is 0.2 cm, so we convert it into meter. Okay, so the rate of heat flow for questions number 25, we will get 9,450 watt. Okay, so the answer is D. Questions number 26, chapter 12. An aluminum rod with the diameter 3 cm and the thickness 0.6. One end of the rod placed in a boiling water, okay, meaning that it's 100 degrees Celsius, and another end is with the ice, so it's 0 degrees Celsius. Calculate the quantity of heat transfer through the rod in 1 minute, and this is the thermal conductivity. Okay, so we want to find Q, what is the heat transfer? Okay, so we can use dQ over dt equals to negative Ka dt over dx, where Q is the value that we want to find, T is 1 minute, so it's equal to 60 seconds, equals to negative thermal conductivity is 205, and the area is not given, but they give you the diameter. Okay, so we can find area is equals to pi r squared. Okay, so since here we have diameter, so our r is equal to 0. So r is equal to 1.5 cm. So we convert it into meter, remember to square. Okay, times the temperature gradient, where the temperature is 0 minus 100 over thickness is 0.6. Okay, so finally Q, or the heat transfer through the rod, is equals to 1449 joule. So the answer is A. Okay, next question, number 27, is chapter 13. An ideal gas 20 degrees Celsius, so later you need to convert into Kelvin, and the pressure is 1.5, containing having the volume 1 exponent negative 3. Determine the number of mole of the gas in the container. Okay, so we can use the ideal gas equation PV equals to nRT to find out what is the value for mole. P is pressure, is 1.5 exponent 5. V is the volume, 1 exponent negative 3 equals to mole. Number of mole is the unknown. R is constant. T is 20 degrees Celsius, so 20 you must plus 273.15, convert it into Kelvin. Okay, so final answer for the number of mole is equals to 0.061 mole. Okay, so the answer is C. Questions number 28, still chapter 13. Determine the average kinetic energy posed by the molecule CO2 at the temperature of 300 Kelvin. So average kinetic energy equation is equals to F over 2 kT. Okay, where CO2 is actually polyatomic. Okay, polyatomic meaning that the degree of freedom is equals to 6. So we substitute 6 over 2. K is the Boltzmann constant, 1.38 exponent negative 23, and the temperature must in Kelvin, so they give you 300 Kelvin. Okay, so the average kinetic energy from that we will get is equals to 1.24 exponent negative 20 joule. Okay, so the answer is B. Okay, next questions number 29 and 30 is chapter 14. Okay, thermodynamics. Calculate the work done post AB. Okay, A to B is actually isobaric process because this is actually P is constant or no changes of the pressure. Okay, so from A to B, actually the pressure is still the same, 3 exponent 5 Pascal, but the volume is actually from 0.2 increased to 0.4. Actually, this is expansion. So work done for isobaric is equals to P times change of the volume, where P is 3 exponent 5. Volume, we must take final minus initial, where final is 0.04, initial is 0.02. Therefore, the work done for process A to B is equal to 6,000 joule. Okay, so the answer is D. Last questions for set 2. In adiabatic process, adiabatic meaning that the Q is equal to 0, meaning that there's no heat transfer in or out in the system. The internal energy of the system gets decreased by 800 joule, meaning that the internal energy decreased, meaning it's negative 800 joule. Okay, which of the statement is correct? Okay, so Q is equals to change of the internal energy plus the work done. So since Q is equals to 0, therefore our internal energy is equals to negative work done. Okay, so we substitute negative 800 equals to negative work done, therefore the work done is equals to positive 800. So if you refer back, which one is correct? The system lost 800 joule of heat transfer. This one wrong because Q is equals to 0. The system performed 800 joule of work by the system. Okay, so by the system meaning that it's positive. So the answer is B. Okay, so if you look at the answer at C, the system gained 800 joule of heat, also wrong because Q is equals to 0. Okay, and for C, the surrounding performed 800 joule of work on the system. Okay, on the system meaning that the work done is equals to negative 800. So this one also wrong. So the correct answer is B. Okay, so see you on the next video. We will continue to discuss on Pre-Pspm set 3. Okay, see you. Bye.